In this lesson, we're going to look a little bit at quadratic functions that are in different form. Now, we spent the last lesson dealing with them in this form. We called this the vertex form. Okay, another name for this is also standard form. Okay, and remember, what was great about vertex form or standard form is that you could read the vertex right off of the equation. What we're going to do today is look at what happens when it's in this form. Okay, one of the things you can do is to change the form, and that's what we'll do in this part of the lesson. Okay, and if you remember last unit I said completing the square is something you would never do by choice. Well, here is where you actually need to complete the square, and this you will use. Okay, so that's why we still did that, those skills in the last unit, because it's very helpful for this lesson. Okay, so let's go to example 1 here, and I see here is general form, and I want to change it to vertex form. Okay, so what do we do? Well, these are the steps, and they're very similar to completing the square from the last unit. The first thing we want to do is isolate the c. Okay, in other words, put all the terms with x by themselves, and then we'll just move the c over there. Now, if you remember last unit, we did the same thing for solving, but because we had a 0 over here, we actually took that constant and moved it to that side. Okay, we're not going to do that now because we have a y there. Okay, second step is factor out the a. Now, in this case, a is 1, so I don't need to factor it out. Okay, next I'm going to take this and make a perfect square. So what am I going to put here so that this entire thing is a perfect square? Well, if you remember, we use this term here, b divided by 2 squared, so take -6 divided by 2 and square it. So this is going to be 9. Okay, and now we got to be careful. I just changed my equation. I put a +9 there, so I'm going to compensate by putting a -9. Right? +9 minus 9 is 0, so now I haven't changed it. Okay, so this is a perfect square. It should be, because that's what I did. I made it a perfect square. So before I squared the 9, it was a -3, so that's factored. And then I have -16. And that's it. What's the vertex then? 3, -16. Okay, so that's a useful skill to have, to change it to standard form from general form. Okay, let's try one that's a little bit more difficult, and you'll see right away why this one's more difficult. Okay, so first step is to isolate the terms with x. Okay, did that. But now we don't have an a value of 1. I need to factor this 3 out. Okay, and so when I say factor out, it's like dividing out. So if I divide the first term by 3, I get x squared. If I divide the second term by 3, I get -4x. And then I'm going to close the bracket there because I'm not factoring the 3 out of the 7. That would get too ugly. Okay, now what would make this a perfect square? Take -4 divided by 2 squared, I get +4. So I put that in here. What do I need to do to compensate? What do I subtract by? It's not 4. It's actually 12. Where is that 12 coming from? It's because it's 3 times 4, right? This 3 has to be multiplied by the 4, so I put a 12 there, so I have to put a -12 on the other side. So factoring this is going to be x minus 2 squared minus 5. Okay, so what's the vertex? 2, -5. Okay. So this one says determine the equation of the axis of symmetry of the parabola. Well, really we need the vertex. We still need to get the vertex so we can figure out the axis of symmetry is going to be x equals whatever that vertex is. So let's complete this square. This one's going to be much more difficult. So we're going to factor out a negative 2. If I divide 5 by negative 2, I get negative 5 over 2. Okay, and now this is a little bit more tricky as well. If I take negative 5 halves and divide by 2, how do you divide by 2? You would multiply by half. So this is negative 5 fourths. If I take negative 5 fourths and square it, I get 25 over 16. Okay. Now, what do I put here? Well, negative 2 times 25 over 16. This is negative 2 times 25 over 16. This is negative 50 over 16. So I have to add 50 over 16 to compensate. Okay. So now let's factor. So this is going to be, what was 25/16 before I squared it? It was 5 fourths. And then if I want to make this common denominators, I'm going to get negative 48 over 16 plus 50 over 16. So y is negative 2x minus 5 fourths squared plus 2 over 16. So that means the vertex is 5 fourths, 2 sixteenths, and the axis of symmetry is x equals 5 quarters. Okay, I believe this is our last example, so I'd like you to try this one on your own. Can you pause and give it a shot? Okay, so how did I get 10? Well, what is 2 divided by 1/5? This is 2 times 5 over 1, which is 10 over 1. Okay. Well, let's make this a perfect square. 5 divided by 2 is, 10 divided by 2 is 5 squared, 25. And then what am I going to have to subtract here? 1/5 of 25 is 5. So y is 1/5 x plus 5 squared minus 6. Determine the y-coordinate of the vertex of the graph. Well, the y-coordinate is negative 6. Okay, I think we'll stop there. So our homework will be page 295, numbers 3 to 10. Make sure you also do the multiple choice. And I've also got on the My Site, so this is first homework. On the second homework on the My Site, there is some questions for this as well. There is a review. Okay, so let's get going on those assignments. I just went and checked. This is called Properties of Parabolas. Okay, there you go.